Types of chemical reactions. So the first type we're going to look at is combination. Combination is exactly what it sounds like. We have two or more reactants that are going to combine together to make a single product. So the example that I have on the screen here is a picture that's showing chlorine gas and sodium metal has been added to it. And we see that this reaction is occurring here. And it's giving off lots of energy in the form of light and heat. And we are forming sodium chloride here. So we have two elements or two compounds coming together to form a single product, a single compound. Decomposition is the exact opposite, where we start with one reactant and it breaks down into simpler components. So the example that I have here is when you take mercury oxide solid and heat it, you're going to form mercury liquid and oxygen gas as well. So we're starting with a compound and it's being broken down into simpler components here. Next is combustion. So combustion is what we think of when we think of burning. So usually it's going to be some kind of hydrocarbon that's going to react with oxygen. Oxygen is always going to be a reactant. You probably know that whenever you cover up a candle, the flame goes out because it's starved of oxygen. So my reactants, one of them has to be oxygen. The other one is usually a hydrocarbon. I have hydrocarbon written as CXHYOZ. Those can be different numbers, X, Y, and Z. That's just the general formula of a hydrocarbon. My products then are going to be carbon dioxide and oxygen. Now there is an exception to every rule. So an example of a combustion reaction where we don't get any carbon dioxide is the combustion of hydrogen with oxygen to make water. So there's no carbon dioxide produced here because we didn't start out with anything that had carbon in it. Single replacement is where one element replaces another. So here we have T reacting with RS. T is replacing R, and now we have TS, and now R is by itself. Now this only works if the lone element, in this case T, is more reactive than the one it replaces, in this case R. So in the video on the screen here, we're looking at potassium metal replacing hydrogen in water, producing potassium hydroxide and hydrogen. So I start with a lone element in an ionic compound, and I end up with a new lone element and a new ionic compound. Only works, though, if that lone element you start with is more reactive than the one it's replacing. Double replacement is a similar idea, but both ions are going to switch. So they're kind of switching partners here. So here I have a reaction of potassium iodide and lead nitrate solution. Those are aqueous clear solutions. When I add them together, though, they form this cloudy yellow solid, which is lead iodide. And then we have potassium nitrate just floating around in the water. So I'm going to start with two ionic compounds that switch cations. And my products are going to be two new ionic compounds. And this is driven by the formation of a solid, gas, or water. So if both sides of the equation are all aqueous for their state of matter, we would say that reaction does not occur. Those ions just float around together in water.